So the easy one is temperature's gone up. Now, we always compare things to some long-term mean, so we don't, pick a particularly warm or cold year or anything like that. And this is, as you see, compared to the mean temperature from 1951 to 1980. This is 138 years of temperature right up to last month. And this shows you that relative to a long-term mean, we've gone up about 0.8 or 0.9 degrees Celsius. Now, that's a global mean. And what I always like to emphasize to my students, that sounds pretty small, and to the public, that sounds pretty small. But it's not 0.8 or 0.9 everywhere. It's really different depending on where you are. There are some parts of the Earth that are getting much cooler, like in the blue you see here. Other parts that are getting quite a bit warmer. Up in Alaska, 3 to 4 degrees C warmer now than it used to be. And so that's about 7 degrees Fahrenheit. That can have a major impact on places that have ice, like Alaska, Canada, Siberia, etc., Greenland. So it's not evenly distributed. There's some places that are warm, some places that are cool. The average, though, is almost a degree warmer. I've also found some great animations. If you don't have them, these are really fun to show your students. Here's a great one out of NASA. The link is at the bottom. And it's a really cool movie to show, and hopefully it comes across on your end as well. If not, you can look at it directly. Not a lot goes on in terms of temperatures until you get up and around the 1980s, and then you see the colors really start to get red, and that's where we are today. So a great animation, and I'll show you some others that are really fun. NASA does a great job of visualizing the data on global change, so I'll highlight some of those that hopefully you find useful. So we think about things that keep getting warmer. We see stories online or stories in the newspaper about how things are warmer. Here's a great quote from CNN, 2016, the hottest year on record. Again, we keep breaking records over and over. We have 138 years of global temperature records. 16 of our hottest years have occurred in the last 16 or 17 years, since 2001. So the only other hot year was 1998, by the way. So this isn't random. It isn't like we have a hot year, then a cold year. 16 of our hottest years have occurred since 2001. Here's another great way to show this. Now, this is the global temperatures throughout the month. And I'll click on this site, and we should get over to the website to show you this. Now, this just plots annual temperatures, of course warmer in the middle. And look how it changes in color and keeps going up. Just another way, instead of looking at just a single point, but looking at it over the months of all the years from 1880 to 2016. Again, this is available from NASA as well, that you can download that for yourself. It's a great little video to show your students. Great Perspective USA Today put out a story a couple of months ago to really give your perspective. How warm is this? And this is quoting a scientist that you can find in that story, that the last time it was this warm was a very long time ago. Give you a sense of, again, this isn't just a random variation, but there's quite a bit of data telling us that this is unusually warm. Of course, when things get warm, they melt. And here's the latest, up to 2016. If you have our book, I think we go up to about 2013 or 14, the latest data we had at the time, just to show you those trends are continuing. You can look at the Greenland sea ice. You can look at the Antarctic sea ice. You can look at the Arctic up in the North Pole, that sea ice. Again, all data from NASA. These aren't, from an environmental group or anything like that. These are data coming straight from NASA on how much sea ice there is. And here's another great graphic from NASA where the gold line, again, we want to compare any kind of global change to a long-term average. The gold line is the long-term average from 1981 to 2010. The way we typically look at how much ice is around the North Pole is we want to look at a time of year when we hit the minimum. That's usually August or September. The polar ice cap gets its smallest, and then as winter comes, it starts growing again. So scientists measure how small did it get when it got its minimum extent, as we call it. So the gold line shows you for 30 years what that average was, the minimum extent of ice. In 2016, you see where the ice is. All the white stuff is the ice. The blue stuff is water. So how much have we lost? About 900,000 square miles. How much is that? Whoops. That's about 3 times the size of Texas. That's a lot of ice, just to give you a sense. We have lost a tremendous amount of ice compared to the long-term mean. So when people think about, and you talk to people about, well, we've gone up almost a degree. Well, up here it may be 4 degrees, which is about 7 degrees Fahrenheit. That small change in temperature has a big effect on things like ice and how much ice there is and when the ice goes out and when the ice comes back, what time of the season it comes in. And here's a great example of that, polar bears. So polar bears, the ice cap leaves earlier than it did 30 years ago. So the polar bears have less time, about 3 weeks less time to hunt for seals on the ice. So instead they have to come on land. The ice flow isn't there anymore. They come on land, they have to eat things like ptarmigan, things that aren't as energetically good for them as seals. And the researchers found that compared to 30 years ago, average male polar bear is about 150 pounds lighter because it doesn't have that time to hunt for seals out on the ice. So a small change in temperature, a few degrees C, has a pretty big change in how long the ice is there for the polar bears to walk out on, and has a really big impact on how much weight they gain, which of course if you're a bear going through the winter, being a bigger bear is a better thing. So these are big consequences. Other big consequences, it's not just the big ice caps that are melting, glaciers are melting, and our most famous probably place for glaciers is Glacier National Park in the U.S. In 1850, it had 150 beautiful glaciers to look at, and today there are 25 glaciers left. And one of the most interesting things that researchers have done is go find historic photos of these glaciers and take the same picture from the same point of view today. And here's one of those examples. Here's a picture in 1940 showing the glacier, exactly the same point of view in 2006. The glacier has clearly receded quite a bit. Here's another glacier in the park, 1941, 2008. There was a glacier, now there's a lake. So it's not just the ice caps that are changing, the glaciers are changing. Lots of great examples of this, and your students will enjoy. This is a great YouTube I use with my students, where they're talking to the researchers, and they're talking to the researchers who work in Glacier National Park about the changes in the ice, but also the changes in the plants and animals as they respond to global warming in Glacier National Park. So that's another resource to think about showing your students. If you go to the International Panel on Climate Change, they've looked at thousands of studies about what else is changing, what kind of biota are changing. And their conclusion is over the past 40 years, plants are flowering earlier. Not every plant, but a lot of species of plants are now flowering weeks earlier than they used to. Birds are migrating early. They're arriving back in their breeding ground. Like this time of year, they're coming weeks earlier than they used to. We know in our area, amphibians are breeding earlier. Insects are emerging earlier. Now, none of these animals, of course, are online and checking that there's a thing called global warming. They just know. They respond to temperature. So the flowers know, and the birds know, and the amphibians know, and the insects all know that spring is coming earlier because the globe is warmer than it has historically been. The fish know. You look at the North Sea. Here's a great example. In the North Sea, the temperature at the bottom of the North Sea has changed about 2 degrees over the past 30 years. Researchers who are working in the North Sea, they do surveys to see what fish species live there. And one of the things you see in the second graph, here's time on the x-axis, how many different species of fish they catch. And in 30 years, they're catching about 20 to 25 more species than they used to. And the reason why is that species from the south of the North Sea are moving up into the North Sea. They're moving toward the pole. And you get more and more species, which initially sounds like not necessarily a bad thing because you got a lot of species and we all think, having more species is a better thing. The problem is those northern species that used to live in the North Sea, including a lot of commercially important ones that people like to eat, are moving farther north, and they're not as abundant. They're still there right now, but they're not as abundant, and they're moving north as well. So we see the whole shift of species moving. simply from a 2-degree change. And if you just correlate that bottom temperature with how many fish, of course, you see a similar correlation, suggesting that the increasing temperature may, in fact, be driving the increase in the different species that we see. Lots of economic impacts. Tourism is changing. Places, this is a shot in Switzerland, places that traditionally have been focused on things like downhill skiing aren't getting the snow that they used to, aren't getting the cold weather that they used to. So they have to adjust to other kinds of tourism to keep in business. One of the really fun stories I like to tell my students, and if you don't know this story, this is a really fun one, in terms of the French, who of course are famous for making some of the best wines in the world. Climate change is changing that scenario. Climate change is making areas of France less ideal for growing grapes for wine, and it's making England more suitable. It's now warmer in England, more precipitation is happening in England, and there's a little blurb here that the prediction is it's still going to increase another couple of degrees in England, and rainfall is expected to increase. But already the British are making better grapes and better wine than they ever have, and the French are having a hard time with their climate change in making the best wine. And nothing, of course, if you know anything about the British and the French, nothing annoys the French any more than the British making great wine and the French having a hard time making wine. So it's another great current impact of climate change that the farmers and the winemakers all are recognizing. This isn't a prediction. This is happening right now. And that brings us to the predictions. Those are all facts that we know. We have the data. We can certainly demonstrate that all of those are currently observed consequences. There are a lot of consequences, though, and I think it's important for my students that we distinguish between what we know and what we predict could happen, but we aren't really sure yet. We can debate these things. And one of them is what's going to happen in the future if we continue to put carbon dioxide and other greenhouse gases into the air. The top panel is looking at a scenario where we kind of get our act together and slow down the amount of CO2 we put in the air. And the bottom series of 3 panels is really if we don't, if we continue to increase how much CO2 we put in the air. And you can look at different time periods, different 20 or 30-year periods, what's going to happen. None of the worst case scenario, we don't get our act together, then North America is going to be about 4 more degrees Fahrenheit warmer, so about 7 degrees Fahrenheit warmer than it currently is. Other places, 6 or 7 degrees Fahrenheit warmer in northern Canada, Russia, et cetera. So those are predictions. We don't know yet how correct they are. We have supercomputers running these models. New models are being developed every year. New data are going into those models. New assumptions are being fixed in those models. But those are the predictions. We don't yet know which one of these is the scenario that we'll actually see. We also predict that lots more species, in addition to those that we've talked about already, will start moving north. And we make predictions like that because here's an example of trees since the last ice sheet was in North America. And we can look at pollen that's laid down in lakes over thousands of years. And we can use that pollen to tell us that since the ice retreated, 20,000 years ago, all of our trees have been moving north. And the expectation is trees will continue to move north as it gets warm, and other plants and other animals. Not a lot of data on those geographic range shifts yet. There's a little bit on that, but that's the expectation. The question, of course, is what about species who can't move fast enough? That's a great sort of ecological question. We don't know really the answer to those questions yet, but that's another prediction that we expect. We expect intense heat waves and cold waves. We expect changing precipitation patterns. We expect more intense storms, hurricanes, tornadoes, etc. We expect more altered growing conditions. We've seen some of that in the story about France and England growing grapes for wine. We expect altered disease. Most of these are really hard to demonstrate. So things like increased storm intensity. If you watch the different media stories about different hurricanes, they often suggest that, well, these hurricanes were predicted to be more intense. The hard part is knowing how much of that is due to global warming and how much of that is due to other impacts that we see. whether it's a drought, whether it's a heat wave. We just went through an El Nino period on Earth last year, so El Nino can have a big impact too. So we have to be careful that we don't just attribute things to global warming because it's much more complex than that. But the prediction is that we should see these 5 things also happen with global warming, and we'll have to wait some time to see if it actually looks like it's playing a role. One of the interesting things is the global passage, the Arctic passage, that, above Canada, that area that's currently frozen will be at some point of the year completely melted. It's not expected to about 2040, but it opens up a channel if you want to go, say, shipping goods between China and Europe. Much, much easier and faster than, say, going south through the Panama Canal. So in some places, there are going to be some benefits to global warming. Now, that in no way means that we should do it, or that that it endorses the activity of causing global warming. But it does highlight that there are parts of this Earth, regions of the world that will see some benefits, and other regions of the world that will see big costs. And there are regions of the world that will see both, some beneficial things, some costly things. But I think it's important when I teach my students that we don't just say everything is bad. It's not correct that everything is bad. We certainly see a lot of bad things. We see some beneficial things depending on your perspective and where in the world you live. But again, it doesn't mean we should be doing this or we should embrace this. It's just a consequence. There will be good things and there will be bad things depending on where you are. One of the really big concerns is shutting down what we call the thermohaline circulation. And if you don't know, this is the big, slow circulation that joins all of the major oceans, and it distributes heat around and between all of the major oceans. And if you start at number 1 on the left in the Gulf of Mexico, this is a surface flow of water that goes up past Western Europe, and as it gets cold, it's salty water, it gets more dense, and that causes the water to drop where number 2 is, and it drops to be pretty deep all the way to the bottom of the ocean, and that's what pushes the rest of the current to move around and distribute heat. It's also why between number 1 and number 2 on this map, Western Europe is relatively warm considering the latitude it's at. If you look at where England is, it's like northern Canada. Just by latitude, you expect it to be quite a bit colder, but the Gulf water coming up there, bringing warm water to Western Europe, that means you're also bringing warm air to Western Europe. All of that helps. The worry is it's the salty water dropping at number 2 that drives this. If places like the polar ice cap and the Greenland ice cap continue to melt and they make that water less salty, that may stop the driver at number 2, and it may stop the whole circulation. And if that happens, Western Europe is going to be a whole lot colder, and the whole Earth is going to have very different temperatures than they currently have. We don't know if that's going to happen. We don't know when that's going to happen, but it's a speculation in terms of one major event that could happen if we get too much fresh water added to this naturally salty ocean water.